Advent of Code, Day 1, 2019.
Good intro. I think we're gonna roll with that one.
Okay,
All
we'll
right.
see.
So I'm just gonna jump right in
Yeah,
to day one. So it's December 1st, 2019,
it is.
and what should we do in December?
Christmas?
Write code,
Oh,
obviously. All right. So Advent of Code is a 25-day challenge. It's been going on since 2015, and they have some problems which you don't need to submit any source code. You just submit the answer, and then it tells you if your answer is right or wrong, and people get different inputs, so that they can't cheat off of each other. Now someone could like post a code like on Reddit or something, you know, or make a YouTube video, something like that, and then I suppose, but since day one's already past the 24-hour mark, I think we're in the clear.
okay.
um, yeah, so the interesting thing is that like nobody compiles any code, like, some things you just give them the answer.
Okay.
Whether you decided to figure it out with pencil and paper, or build a circuit board or write some code. Probably most people are writing code.
Okay.
All right, so let's take a look at what this looks like. All right, so we get a there's a bit of a story that progresses throughout the 25 days. All right, so Senna's become stranded at the edge of the solar system while delivering presents to other planets. To accurately calculate his position in space, safely align his warp drive, and return to Earth in time to save Christmas. He needs you to bring him measurements from 50 stars. All right, so every day you get 2 stars. So
Okay.
that's why you get 50 at the end.
Okay.
All right. So collect stars by solving puzzles. Oh, I didn't have to explain any of that. It's gonna be all right here.
Well,
two, two puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. So usually part two is like a progression of part one. Very rarely I've seen like you kind of have to write like a completely different program to solve part two. Anyway, uh, each puzzle grants 1 star. Good luck. The elves quickly load you into a spacecraft and prepare to launch. At the first go no go poll, every elf in go until wait, every elf is go until the fuel counter upper. They haven't determined the amount of fuel required yet. Yeah. Fuel required to launch a given module is based on its mass. Okay, so now we're getting into like where we're actually want to start paying attention. All right, so fuel required to launch a given module is based on its mass. Specifically, to find the fuel required for a module, take its mass, divide by 3, round down, and subtract 2. So divide by 3 and round down. So like, for example, if you had like 2/3, you get like 0.666, right? But when they say round down, they want you to go down to 0. So we're working only with integers.
mm-hmm.
And so that's fine. If you're working with a language that has integers, like anything except for JavaScript, mostly, probably, then this would probably be default behavior. So we don't need to necessarily worry about that too much. All right, so for example, so anytime they say for example, it's a good indicator that we probably want to
Pay attention to the steps that they're taking.
pay
Okay.
attention to maybe some of the more detailed description that they're giving if some of it was unclear before, and if we want to maybe write some tests to test our code before they give us, so they'll give you some simple cases, and then your case will be difficult,
Okay.
more difficult. All right, so for a mass of 12, divide by 3 and round down to get 4. Okay, so 12 divided by 3 is 4, then subtract 2 to get 2. Okay. For a mass of 14, divided by 3 and rounding down still yields 4. So the fuel required is also 2. For a mass of 1969, the fuel required is 654. For a mass of 100,756, the fuel required is 33,583. The fuel counter upper needs to know the total fuel requirement. to find it, individually calculate the fuel needed for the mass of each module, which is your puzzle input, then add together all the fuel values. Okay, so we're gonna get a bunch of numbers like 12, 14, 1969,
Yeah.
etc.
And then we need to calculate the numbers like the 654 and 33,583. Then we need to add all of those together to get the answer.
Yeah, that sounds right. So, all right, so we can start writing some code, and then we'll come back to this as like our test input. All right, so let's put this over here so we can kind of like keep it in view. First thing we want to do is create a new main.go. Not package part 1, but package main.
And do some people do this in other languages, right?
Of course.
Okay.
All right, so we have a func main, but I'm not going to worry about my main function right now. Maybe if I wanted to run this from the command line, but I'm mostly going to be running this through the Go test. All right, so I need a function that calculates the fuel given some mass input. All right, so they said, go back to this. So take its mass, divide by 3, round down, divide by 2. So it's really that simple. So that's the fuel required for a given mass. And
Because this automatically does the rounding?
yeah.
Okay.
So, yeah, when you divide two integers, it typically depends on the language and actual implementation,
But for Go, this is what it does.
correct. Yeah, pretty much everything. I really can't pick a good example. So I'm going to write a test function. I'm going to test my fuel function. All right, so let's just make sure that we can access that. Great. So I got a couple different cases, and I'll get that over, don't worry. All right, so let's make this so we can keep seeing it. All right, so we're going to be concerned about, so we're going to make a data type, and we're going to make a slice of that data type. We're going to have our input, which is just going to be the mass, and then we're going to have our output, which will be the fuel.
Mm-hmm.
So we're going to have a mass that we're going to put in, and then we're going to have an expected value. And from here, I'm going to just make 1, 2, 3, 4 spaces, and I'm going to fill in their data. So we got 12, 14, 1969, and then a large number that I don't want to type by hand. All right, and let's see, this is 2,
654,
and
a large number you don't want to type by hand.
yep. All right, cool. So those are our test cases, and then we want to like just run through the mouse and make a for loop. So the C will pull out the one of these at a time,
Okay.
and then give our subtest a name. So we call this like mass %d for digit, and I'll just pass in the mass. All right, so this just runs a subtest. If you look at the documentation, you give it a name, and then you give it like another test to run. You don't necessarily have to do this, but it's nice to give that name. Like you could just do this in a for loop without like this part. All right, so this is what we're gonna actually call, right? So we're gonna pass in a mass, and we're gonna get some actual value. Now, what we want to know is if our expected doesn't equal the actual C expected, right? Then we want to say, hey, I wanted this, but I got this instead, right? So C dot expected, and then actual, right? And this should pass, hopefully. All right, so let's pass it. So let's make sure it's not just passing by accident. Change one of them run it again, we should see a failure. All right, good. So I want this, and I got this. Because we changed what we wanted. We didn't change the function. So.
Yeah.
All right, so we got our calculation working correctly. So now it's time to get our puzzle input, which is a whole lot of numbers. So I'm going to save this as input.txt in here. All right, and no longer interested in that. Come back over here. There's our input.txt. All right, so we need to read this file. So let's see.
Are you doing this in the test?
Yeah, we'll
Okay.
do we'll do this in the test too. So we'll say func test. So I'll test functions and goes over test, and then the next letter is a capital letter of anything. So we'll just say read file. Actually, we don't know, so it's fine. We don't have to do that. So I'm skipping that for now. All right, so we need to read a file. Give it a file name, and we'll say our answer is read file input txt, and then we'll say just print the answer, right? So we're expecting this read file function to return our answer. So first thing we need to do is get all these numbers out of here, and then calculate the fuel, and then add them up. All right. So how do we want to read the file? Let's see. There's a couple ways, but one way. See, there's another thing we want to do. I'll come back to that in a second. So let's say OS open file name. And then if you get an error opening the file, like file not found or something like that, you're gonna want to kind of like return this error. Like I could just log .fatal, which would like abort the program, but if I did eventually have like a read file test, I wouldn't want to crash anything. I would just want to like get the error back, right? So so instead of returning just an integer, I'll return an integer and an error. Here I need to change from green, if error is like nil, then here we'll log fatal. Cool.
Mm-hmm.
Okay. So when we leave this function, we want to make sure we close the file. Don't want to leave any open file handles or anything like that. Now we need to actually go through and like read all the stuff out of this file. So we're going to create a new file scanner. New scanner. We pass it in io.reader. io.reader is an interface, and the file that we get back from os.open implements or satisfies that interface. So we can pass the file to the scanner. The scanner gives us some nice stuff that we can leverage. So we're going to for scan. Scan just returns a bool, and it's going to just return the next token, which in this one's case is basically going to give us like a word at a time. Hopefully that's right.
We'll see.
Yeah, we'll see. All right, so we're going to do some stuff in there, and then one thing that's really, really important that unfortunately some people do not do is actually an issue open on static check. Static check is a common like linter that's used on Go code, and one of the issues that's open is like look for improper uses of the scanner where people don't check the error after they're done scanning. It's a very easy thing to do. It's like you go through your file, everything seems fine, but this is just how scanner works. Is that if there's an error, then your next call to scan returns false, and your error is returned in this error method, right? So you need to check it when you're done. All right, so if we got an error, we'll just return 0. Usually any kind of value that we return, it's going to get ignored, and then whatever the error was. Okay, and then we'll have more stuff to do here. All right, so once we've scanned, then we can access s.text. right? So it returns us some text that we scanned out of the file, and what that's going to be is like one of these lines, and we need to convert it to an integer, right? So a couple ways to do that. For just a line that's only an integer, I'll just use a strcom string convert ATOI, ASCII integer, throw back to C.
Okay.
And then you can just like, literally pass it s.text. And since we're returning, since your text might not be an integer, right, it might fail to parse, and you get an error back in that case. So we'll say, when we read out here, so we're going mass and error equals this, and then if I'm not able to parse it, then we're done, and we just return the error, whatever it might be. You know, we might want to add some like additional context here, like you can't parse this, right? So we might be able to tell them like, hey, this text I couldn't parse, and here's the error that I got.
Okay.
Okay. So then don't forget we got our fuel function here. So we got fuel of mass. So we have F colon equals fuel mass, right? And then maybe we have like total fuel, right? All right, total fuel plus equals F. So we're gonna add our fuel calculation to something that's going on. So we're actually would be done here. So we'll return F and no. So no error, not F, but total fuel. So let's go over this again. So we open up our file, make sure we don't have an error. We make sure that we close the file once we exit the function. So we would do this, we do the defer so that like any way that we return, whether it's an error here, or if it's an error here, or if we make it all the way to the end, or even if it's a panic, we would make sure that this f.close always happens. So if you always want to make sure, you know, your alternative would be I would have to write like f.close here.
Yeah. In every instance.
Yeah, and then I have to write like another one here and then another one here.
Yeah.
And then if there was a panic, you know, I'd still need to, like, you know, pretty much in that case, you wouldn't be able to handle it. Sometimes there's code that like doesn't panic and like you can get away with that, but whatever. All right, so we create a new scanner, which is just kind of like a helper that will help us read, you know, words from any kind of IO.reader, which is in this case our file.
Mm-hmm.
And then we call scan, which returns true as long as it's able to retrieve like a new token, some new text for us to read. And when we call the text method on the scanner, we get that text back. So it's going to be, we can actually print that out if we wanted to, just to kind of like see what it does.
Mm-hmm.
And then we do, we convert ASCII integer, we get the mass, right? We check that we didn't have an error as we were
going through everything.
Well, in this particular case, we checked that the error wasn't on parsing. So if there was like, you know, 1, 2, 3, ABC, like this would fail because you can't convert that to an integer, right? Mm-hmm. Then we just do our fuel calculation based on the mass that we got, and we add whatever we got there to the total fuel. At the very end, we make sure that we didn't get any errors from the scanner itself. And we return the total fuel. I think we're ready to go with this. So let's see, I'm in C project 2019 01 part 1, right? Just to go run dot. All right, that should be my answer. And ta-da!
You got a gold star.
Oh, I'm excited. So we got one. Now we gotta do one more.
Yes, because you get 2 pieces to each.
I was looking at the time.
Oh, that's okay. Let's keep going.
All right. I think I'm gonna.
Isn't there a second part to
There
number
is
1?
a second part, but I think I'm gonna pause and review this video.
Okay.
So I can critique myself.
Yeah, I could chime in a little more, but.
Huh?
I could chime in a little more.
You could say more things, you mean?
Yeah, we probably can.
Yeah, I could probably say less things.
Well, we'll figure it out. Let's go through it.
All right.
Okay.
Stopping now.
This is fun.
It was fun.
I like doing